Guys, so now we start passage 4. Okay, so certain layers of Earth's atmosphere absorb particular wavelengths of solar radiation while letting others pass through. Types of solar radiation include X-rays, ultraviolet light, visible light, and infrared radiation. The cross-section of Earth's atmosphere below illustrates the altitudes at which certain wavelengths are absorbed. The arrow points to the altitudes at which solar radiation of different ranges of wavelengths is absorbed. The figure also indicates the layers of the atmosphere and how atmospheric density, pressure, and temperature vary with altitude. So we got an interesting figure over here. We got altitude in kilometers for the y-axis. This is like a triple graph over here. We've got atmospheric density. We've got atmospheric pressure over here for the x-axis, and average atmospheric temperature over here for this x-axis. And yeah, we got the measures. And then we got tropopause, stratopause, mesopause, the different layers. And we have X-ray and ultraviolet light. Let's just get a magnifier on this. X-ray and ultraviolet light, ultraviolet and visible light, infrared radiation. Thermosphere, mesosphere, stratosphere, and troposphere, the different layers. Okay. According to the data provided, at what altitude is the upper boundary of the thermosphere located? So let's get a snip of that. Well, actually, we don't really have to, but according to the data provided, at what altitude is the boundary of the thermosphere located? 150 kilometers, 200 kilometers, 250 kilometers. The upper boundary is not included on the figure. But let's look at the thermosphere. Where is the thermosphere? The thermosphere is about right here. The altitude is about 80 kilometers if you look carefully. It's about 2 away from 100. I'd say about 82, 83 kilometers. Wait a second, we don't have that option. Where is the thermosphere? At what altitude is the upper boundary of the thermosphere located? So the upper boundary. I have to say, I can't find the thermosphere location over here. I believe that the answer is the upper boundary is not included in the figure, on the figure. Let's look at 18. It should be J. '18 is J. I was right. Okay, so the answer to 18 is J. The upper boundary is not included in the figure. Sorry, that's my cousin. I'll get back to her after this video. And my phone will ring in any second. Love my cousin, but I gotta ignore her for a while because I gotta finish this video. In fact, I'm actually doing this partially for her. So I guess that justifies me ignoring her for a while. Although I love her. Okay. So the ozone layer, let's get a snip of this. Oh gosh, new. The ozone layer selectively absorbs ultraviolet radiation of 2,000 to 3,000 angstrom wavelengths. According to the information in the data, which atmospheric layer contains the ozone layer? So the ozone layer selectively absorbs ultraviolet radiation of 2,000 to 3,000 angstrom wavelengths. According to this information and data, which atmospheric layer contains the ozone layer? Let's take a look at this figure. Ultraviolet radiation. Ultraviolet light is 2,000 to 3,000 angstroms. And the layer for ultraviolet, right, is actually, as you can see, the stratosphere. So the answer should be B. Let's check just to make sure. Number 19 is B. I was correct. The information provided in the figure indicates that the air temperature in the troposphere is least likely to be influenced by which of the following wavelengths of energy? The information provided in the figure indicates that the air temperature in the troposphere is least likely to be influenced by which of the following lengths of energy? 1,500 angstrom, 4,500 angstrom, 6,000 angstroms, or 7,000 angstroms. So the information provided in the figure indicates that the air temperature in the troposphere is least likely to be influenced by which of the following wavelengths of energy? So the air temperature in the troposphere is least likely to be influenced by as you can see, average atmospheric temperature, let's snip this question. The information provided in the figure indicates that the air temperature in the troposphere is least likely to be influenced by which of the following in the troposphere is least likely to be influenced by which of the following wavelengths of energy. So troposphere is over here. Troposphere is over here. It's least likely to be influenced by X-rays and ultraviolet light because X-ray is all the way up here, and the second it's least likely to be influenced by is by ultraviolet light, and then it's probably going to be influenced by ultraviolet and visible light between 3,000 and 7,000 angstroms, and infrared radiation between 7,000 and 1 million angstroms. But ultraviolet light between 2,000 and 3,000 angstroms, and X-rays and ultraviolet light between 1 and 2,000 angstroms are out. So X-rays and ultraviolet light between 1 and 2,000 angstroms. But we don't have any of these options. So which of these angstrom levels is it least likely to be influenced by? Well, if we go back to the graph, we see that between 3,000 and 7,000 angstroms, they have they hit the troposphere. We need something less than 3,000 angstroms. And the only thing available for us is answer F. So F is the correct answer, 1,500 angstroms. Okay. So the answer over here is F, 1,500 angstroms. Let's do a new snip of 21. On the basis of the information in the figure, one could generalize that atmospheric pressure in each atmospheric layer increases with. On the basis of the information in the figure, one could generalize that atmospheric pressure in each atmospheric layer increases with decreasing temperature, decreasing altitude, or increasing altitude. On the basis of information in the figure, one could generalize that atmospheric pressure in each atmospheric layer increases with. Okay, so atmospheric pressure is over here. In millibars right here. Atmospheric pressure increases there is no significant increase or decrease with temperature, but with altitude it increases. With atmospheric pressure does seem to increase with altitude, as you can see over here. As altitude goes up, so does atmospheric pressure actually goes down. So since atmospheric pressure goes down as altitude goes up, that's an inverse relationship, which means that and the atmospheric pressure in each atmospheric layer increases with decreasing altitude. And let's try to check if that answer is correct. 21 is C. Yep, I was correct. Okay. Atmospheric boundaries are higher than usual altitude above areas that get more direct solar radiation. Based on this information and the data provided, which of the following predictions about atmospheric boundaries would most likely be true if Earth received less solar radiation than it presently does? So atmospheric boundaries are at a higher than usual altitude above areas that get more direct solar radiation. So atmospheric boundaries are at a higher than usual altitude above areas that get more direct solar radiation. Based on this information and the data provided, which of the following predictions about atmospheric boundaries would most likely be true if Earth received less solar radiation than it presently does? Okay. Incoming solar radiation. The answers are the tropopause, stratopause, and mesopause would all increase in altitude. The tropopause, stratopause, and mesopause would all decrease in altitude. The tropopause and stratopause would increase in altitude, but the mesopause would decrease in altitude. The tropopause would decrease in altitude, but the stratopause and mesopause would increase in altitude. Well, if atmospheric boundaries are higher than usual altitude above areas that get more direct solar radiation, if Earth received less solar radiation, then the altitude should decrease. G. Let's check. 22 should be G. I was correct. Okay, so that should be today's video. Please subscribe, and you can hit me up with any questions on my Facebook or dabarshikunduzero@gmail.com. Thank you. Bye.